Okay, just to briefly go through the presentation from the RDS on Thursday the 30th of May. So data privacy and the abuse of our data by large companies and these large data silos is not news to anyone at this stage. I think it's fair to say that we believe Facebook can influence our thinking, our voting, and certainly what we buy. This goes back to at least 2013, and some would say even the beginnings of the internet itself and its architecture, but certainly there was an explosion in interest in 2013 when we discovered the NSA was harvesting millions of emails. And it's reaching a kind of a fever pitch at the moment. These are some headlines that I've just cut and pasted from the internet over the last few days or a couple of weeks, very recently. And I didn't have to search very hard for any of these. There's scores of these out there. And the point is that if you're expecting a large company, one of these large data silos, to take care of your data and respect your privacy, you're going to be probably severely let down and mistaken. Because the days of innocence on the internet are pretty much over. These are some excerpts from an essay that a chap called Strickler wrote, and he is a co-founder of Kickstarter. And this again is from fairly recently, from May 20th, so not too long ago. And he is exploring the idea that the internet is now a dark forest. And this is borrowed from a science fiction book called The Three-Body Problem. And in summary, it basically suggests that the reason we haven't heard from another civilization in space is because it's just too dangerous. Either they are way more advanced than we are and will come and destroy us and take all our resources, or vice versa. So the analogy doesn't fit exactly, but the point is that people are starting to understand, or they're starting to move from this age of innocence to viewing the internet as a place where you should not be revealing anything about yourself, that it can actually be dangerous to give up your privacy cheaply. And even Facebook is starting to make noises, along with some of the other big companies, in this direction. So they're talking about shielding messages in ways that they themselves can't read. And this is interesting because if you couple this with a couple of other tools that are on further slides, this would allow Facebook to move from being a publisher to being a service provider. Currently, if you post some hate speech to a Facebook page, Facebook is expected to curate that. But if you take the same content and email it to the same people, Gmail, if you're using Gmail, is not expected to do anything about that. Facebook are also talking about using decentralized logins, and this decentralization would also is another step along that road. And then finally, the pièce de résistance is this global coin, which they're talking about rolling out. And I guess if you are making all of your money out of selling your users' data to advertising agencies, if that is curtailed, you may need to think about another revenue stream, or just get into payments in general. And so that's an example of what they may be doing. Now, how they will embrace this, or how aggressively they will go after this, is remains to be seen. You can see here that the Guardian author says that their poor track record may be a big hurdle to success, because of course it's not really in the interests of these big companies to change what they're doing. They've made their fortunes out of selling your data to advertisers. On the other hand, they are technology companies, so maybe they will embrace it fully. That remains to be seen. But the point is that the interest in these kinds of systems, where the user has full control over the data that they send and who reads that data, and even over the data that they receive and where that data is stored, these kind of systems are being recognized as having value. And so this is exactly the type of system, or exactly the type of network that OpenStar facilitates and enables. And I'm just going to go through a couple of fairly random features to tie it back to distributed ledger technology and how OpenStar leverages distributed ledger technology to meet some of those goals that we just talked about. End-to-end encryption. So if I am Bob and I'm trying to send an encrypted message to Alice, I need to know what public keys Alice associates with her identity. So I may have a key from a while back, but she may have lost that corresponding private key and may be now using a different key. So what I need to know is what is Alice's current set of public keys. So I need to have a shared view of this truth, a single source of this truth. I need to validate all of the updates to that, so all of the changes that Alice has made to her public key. And I need to know that she was able to do that in a way that's difficult to prevent. In other words, that she was able to use some kind of decentralized system which she doesn't depend on a single central authority to do this. And this, of course, is a perfect description of a distributed ledger. So in OpenStar, a distributed ledger is used to associate your identity with a bunch of keys. And then Bob is able to discover what Alice's keys are, create the shared key, send the message to Alice, and Alice is able to look up Bob's public keys and confirm or verify his signature on the message. Choice of operator, like email provider. Currently, you would send any message off to the provider, so Gmail or Facebook servers, for example. But trying to give the user some choice, we utilize a similar pattern and associate the user with a particular provider. So when Bob needs to send a message to Alice, he looks up Alice's provider in the DLT and uses some of those. User-controlled paywall. In a smaller network where identity is expensive, so you trust all of the identities that are interacting, or you trust them enough that they will not spam or try to take down the network, then you probably don't need any kind of anti-spam token or micropayments. However, in larger networks where identity is much cheaper and there's the possibility of spam, you may want to charge people for your attention. So what OpenStar allows is a whitelist whereby anyone who's on that list doesn't have to pay, and anyone who isn't has to pay an amount controlled by the user in order to get your attention. Now, if you're going to transfer value, the same rules apply as might apply to Bob updating his public keys. In other words, those transactions must be validated. You should be able to audit the monetary policy of the micro payment that you're charging, and it should be difficult to prevent anyone from using this system. So this again is a natural description of a distributed ledger. And OpenStar provides a UTXO style database similar to Bitcoin, and then from there you can choose the particular monetary policy. So it could be just a set amount, or it could be an expansionary policy like Bitcoin's policy. It's up to the author of the network. And then going back to the sending messages and using a provider, those providers may not be altruistic and may require an actual payment for those store and forward services. So, for example, 10 credits might get you 10 hours before they decide to delete it if Bob doesn't pick up his messages. And so when you have all these things put together, you're able to create some rich message content. And these are the workflows that we talked about. So on one end, you might have a very simple workflow like emailing, and where all the replies are simply events in the workflow. A Facebook post with replies and likes would also fit into that simple category, all the way up to any kind of business process, or even gaming, for example. Another popular one is you could play poker. I mean, that's just another workflow with a bunch of events represented in your client. And so just to outline what an OpenStar node deployment looks like in terms of just a block diagram. So there's a chain, and a chain consists of several ledgers. So these ledgers build on top of each other and may interdepend in one direction only. So ledger 2 depends on ledger 1, ledger 3 depends on ledger 2. 1 might be identity, 2 might be the UTXO style database for value, and then 3 could be, for example, a booking engine. And in once you have those that set up and you have your ledgers and all your transactions are flying around, that's all your shared state taken care of. Beyond that, you would snap in workflows. So W1 and W2 just represent 2 workflows. So you would need the workflow representations for the workflows you're interested in, but not others. In other words, using the same chain, different people may have different sets of workflows installed, and these snap in to your client on top of the chain. Another difference between how OpenStar works and how, say, for example, Ethereum works, when you have an Ethereum global ledger, you're using the same ledger for CryptoKitty transactions and large financial movements. OpenStar will allow you to support different chains. So chain 1 might be your Saturday morning soccer organization, which is some kind of inter-sports company booking engine. And chain 2 might be solicitors of the Northwest, where you're interested in buying some property in Donegal. So OpenStar basically supports multiple chains as a way of scaling. And then finally, just to indicate, is just another diagram showing the different chains. And really the important point, I guess, to remember is that only the reliably shared state goes on the chains. What's more important is all of the encrypted events and the workflows that you build on top of those.